Okay, today I'm going to go through an electricity topic test from Edexcel IGCSE for the physics syllabus. These are the equations that they gave in the last few years, and I think they're going to give something very similar this year in the IGCSE. So if you're revising for your IGCSE Edexcel physics or double science, this run-through will help you. These are the equations. You need to also know the units for each of these, and obviously you need to know which symbol stands for which quantity. So the most complicated one is I for current. Okay, I think most of the others are well known by students, although charge, Q, may be new to some of you. So charge is always Q in physics, current is always I. Okay, the rest of them I think you should be able to work out. And then you need to know which units to use for each one. Power is watts, current is amps, voltage is volts, and time is in seconds, and charge is in coulombs, and energy is in joules. Okay, so that takes us through the units, and we put this test together for students to practice electricity questions, and the first one wants you to draw a circuit diagram. So they gave you just the battery, the 3 cells at the top, and they gave you one of the bulbs at the bottom, and then they ask you to complete the circuit diagram. Yeah, so we're looking over here, complete the circuit diagram by adding a resistor in series with the lamp and battery. So there's the resistor, yeah, in series with the battery and the original lamp, so that works. And then secondly, so that will get you 1 tick. Second one, a second lamp in parallel. There's the second lamp in parallel, so that's the second tick. The third one says a voltmeter that measures the voltage across the resistor. Now remember, voltmeters always go across a component. They don't go in series with the circuit. So this is the voltmeter across the resistor. Okay? And finally it says the ammeter that measures the current in the resistor. So that will be anywhere in the circuit except for where the current is split between the 2 bulbs. Okay? Because when it's split, it will not be the current that goes through the resistor, which is a total current. Okay, so that will get you the 3rd mark, and here will get you the 4th mark. Hope that makes sense. It then says the current in a resistor is measured for different voltages. You can see the readings that are taken, and then they want you to plot the data. So they're giving you 4 marks for plotting. Now for getting all the marks, you need to make sure that you have the labels on the axes exactly as here. So these are the labels you need to put: voltage in volts, current in amps, and it doesn't tell you which way to do them, so they will be the labels. So you need both of those. Okay, and then the scales, you need to have sensible scales. So you go up, for example, in you see how many on your grid for the voltage. You need to get up to 6.0 volts in multiples of 0.5 or 1.0, depending on how many squares you have. And then this is exactly the same, except it's 0.6 up to 0.6, so it'll be a factor, like a tenth of what you do for the voltage axis. So the scales are important. Always make sure each square is worth something reasonable, yeah? A round number, like 1s, 2s, 5s. And then you get 2 marks for the accuracy of your plotting, and they will check that you have plotted accurately. Any misplot will lose you 1 marks. Okay, now one of the pieces of data, it says is an anomalous point on the graph. Your job is to circle the one that you think is anomalous. Anomalous means one that does not fit the pattern, okay? And that will be one that does not fit on the line of best fit, okay? And a line of best fit means you draw it with a ruler. Okay, so once you do that, you can see it will look something like this. Now you can see that I've made one mistake. When I initially plotted, you can see I put my mistake, I held my hand up, and I would have lost one of my plotting marks. And there's another mistake I've made. I haven't written the second, I've got the label here, but I have not put the label here. There's no label on this graph. Okay, so what should you put in there? It should be current in amps. Once you've done that, you can see my scale. Each square is going up for the current in 0.1s, and my voltage is going up in 1s. So that's a nice number, makes it easy to plot. That means the big squares are worth 1, and there's 10 in between 1 and 2, so each of the little squares in between is 0.1. Okay, so that makes it easier for you to plot. And then I would have to circle my anomalous point, and the anomalous point is the one that does not fit the pattern. It doesn't fit on the straight line. Okay, so I've then drawn my line of best fit, and I could have continued that line beyond the last point to extrapolate it beyond the maximum value on the graph that I plotted. Okay, so obviously at 7.0 volts, it should really reach 0.7 amps. Okay, it then says state the equation linking voltage, current, and resistance. So I've pointed to the word, from the word in the question. I have pointed to the correct symbol that I've used, and that should prove to the examiner that I know that current is in amps, voltage is in V, and resistance is in R. So that's a clever way of doing it, where you don't have to write out the whole words. And then for those of you who don't know how to change the equation round, I've put the triangle there, but they will not give you the triangles. They give you the equations, and you've got to be able to work out if you want to find the value for resistance from the graph, which is an ohmic conductor, which means wherever you take the value on the line, the straight line, you will get the same answer. So I decided to take the maximum value at 6 volts to work out the resistance. I want to work out the resistance, which is the bottom of the triangle. So it's V over I. So changing the equation round, R equals V over I. Put the numbers in, you get 1 mark. Put the answer with the correct units, which they've given you. 10 ohms to 2 significant figures is all you need to put. Why is it 2 significant figures? Because the data provided is only accurate to 2 significant figures. Okay, so that's 13 marks, a good revision for those of you doing electricity. Here's the mark scheme for the first question, so it shows you what they'll give marks for, and you can have a look at that by stopping the video and seeing if you've put something different, if you can make sense of it. That will help you. Okay. So that's one question done. The next question is a parallel circuit. It says diagram shows a lighting circuit in the house. The circuit is protected by a fuse F. So here is the fuse. Now where should you put the fuse? You should put the fuse on a live wire. They can show you as mains electricity. That symbol shows you as alternating current. And it says give 2 reasons why the lamps are wired in parallel, and that's so they can be worked independently. They can be switched on and off independently, and they all get the same voltage. For additional detail, what voltage do they get? They get the mains voltage, which should be around 230 volts. So mains voltage, this symbol shows it's AC voltage, and if it's mains, it'll be around 230 volts. So the top, the one with the fuse, is the live wire. So if in your plugs, that'll be colored brown, and the neutral will be at the bottom. Okay. So the neutral wire will be the blue one, so the blue wire will be at the bottom, and the live wire is the one with the fuse, because that's the one which is dangerous. So if there's something wrong, you want the fuse to be activated and cut off the live part of the circuit. All right, there is a third way that they would accept the answer. So we'll have a look at the mark scheme to see what would be an alternative that they would accept for the 2 marks of this question. But the answers I've given you are the best answers, okay? It then says, what is the current value at P? Yeah, so at P on the circuit diagram, it's here. So that's when all the wires join up again. So this is the circuit value at P. I'm going to change the color. So at P, what is the current? So it's over there. So that's when all the paths combine again, and in a parallel circuit, the current splits up and then rejoins. So let's have a look at the circuit. So the current comes from the live wire where the fuse is, and it goes down each lamp separately. You can see each of the lamps has a different current in it. So for example, the first lamp has 0.26 amps. The second lamp has 0.43 amps. That means it's brighter. 0.17, a dimmer lamp, and 0.26. These two are identical lamps. They both use 0.26 amps. They've all got the same voltage, which is the mains voltage. Yeah, so you can work out that when the current goes back to P, all of these currents that go through each of the paths will add up, will be the addition of all of these values. So that's what the current at P will be equal to. And if you add up those numbers, it must be D. You'll get 1.38. Okay? All right. Next question. Explain how the fuse protects the circuit. So this is a very common GCSE question. And if you learn the way I've written it for you, and another question comes up in your exam, it's a guaranteed minimum of 3 marks. So the first thing you need to say is if the current exceeds the fuse value. If the current exceeds the fuse value, yeah, or the fuse current, the value of the fuse that you've put in, the fuse wire gets too hot and subsequently melts. This cuts off the current at the live wire, or you could say it breaks the circuit. So it's now an incomplete circuit. So there's 3 marks already. And you could say this prevents wires or the cables themselves in the circuit from overheating, which is a potential fire risk. If the cables get too hot and melt, and they're touching a carpet, for example, in your house, then that can lead to a fire. So it's better to obviously cut off the current if something goes wrong. All right, then it says state the equation linking power, current and voltage. So again, you choose the correct equation, and the way I've done it, I've drawn an arrow from power to P, current to I, and voltage to V, so the examiner can have no doubt that I know what each symbol stands for. So now you've got to use it. They want you to calculate the power of lamp L. Lamp L in the circuit is 0.26 amps. So lamp L is this one, and this one has a current of 0.26 amps. Okay, so you go back to the question, you put the 0.26 amps in, and they're telling you that you assume that the mains voltage is 230 volts. So we know the voltage, we know the current, multiply them together. If you do it to 3 significant figures, you get 59.8 watts, and you could round it up to 60, because most of the data we have is, or all the data we have is accurate only to 2 significant figures. Okay? But finally, they want you to use another equation, the energy transferred equation, which is power times time, yeah? And they've told you they want to know how much energy is transferred in that lamp if it's been left on for 3 minutes. Now 3 minutes, you need to convert that into seconds. that will give you 1 mark. So 180 seconds will get you 1 mark. Putting the numbers in, so the power was approximately 60 watts, that will be fine. 2 significant figures. And if you use 59.8, that will be fine too. They'll give you 10,800 joules. Don't forget the units, because they haven't given you the units this time. 3 significant figures, and you can round it up to 2 significant figures, and that will be fine as well. Again, remember, the data provided is only known to 2 significant figures, and that's how you know how many significant figures to quote in a physics exam. There's the mark scheme, so you can pause the video, take a look, and see if you've written something differently, what will they accept, what won't they accept, and also when you're reading these, check the notes for clarification. But remember, they've written these notes for examiners, and therefore examiners are teachers. They haven't written it in student-friendly language, so you may be confused. So ask your teacher if they can help you if you're confused. All right, so that's part D, up to part D done. The question then continues with a two-way switch in a lamp. Now these two-way switches means at one end of the corridor, for example, you can have switch 1, which will put the switch one way. At the other end you have of the corridor or stairways, for example, you've got switch 2. Okay, now both switches must be working together to switch on the circuit. So you can have either the switch 2 on X when switch 1 is on W. That will ensure that the circuit is complete, and that will be a tick. Yeah, and the other way you can have them both on is if the switch 1 is on the bottom part, which is Z and Y. So therefore the next correct way to do it would be if Z and Y are both working together and producing a complete circuit. So these are the 2 ticks, and the other combinations will be an incomplete circuit. The circuit will not work. So that's how you get the 2 marks. Okay. It says suggest where this circuit would be useful in the house. Well, I said stairways, corridors, and sometimes in bedrooms where they got the main light when you enter the bedroom, and then you can also switch it off by your bed. Often used this way in hotels. Okay, so that's another question done. And if you're my students, we've already been through these in class. This question is now about how voltage is split between components in a circuit. A teacher uses a circuit, it says, to investigate how the current in a circuit changes with the temperature in a room. Now, what you would be thinking, okay, what's the temperature got to do with? Well, the temperature affects the thermistor, which is this symbol here. Okay, so this is a thermistor. Okay, it's a resistor with what looks to me like a spatula going through it. So that's the thermistor, and it's in series with a fixed resistor of 140 ohms. Okay, the total EMF supplied by the battery or the cell is 1.5 volts, and that 1.5 volts is shared between the fixed resistor, which takes 0.91 volts, and the rest will go to the thermistor. Okay, so how much will the thermistor calculate the voltage across the thermistor? Yeah, so remember the voltage of a cell is always shared between the components in a series circuit. So you'd basically just got to do 1.5 minus what the resistor gets, and the rest of the 1.5, which is 0.59 to 2 significant figures, is the voltage that the thermistor will get. That's 2 significant figures, because that's what you got for the voltage of the fixed resistor. Okay, hope that makes sense. It then wants you to use V equals IR, the formula linking V, I, and R. Okay, so you either write it in a word equation or you can use my method. I think my method will work for the Edexcel IGCSE, and they want you to calculate this time the resistance of the thermistor. Now, because you've worked out the voltage of the thermistor is whatever is left of the 1.5 volts, which is 0.59. You divide that by the current in the circuit, and the current in the circuit is given here. The current is 6.2 milliamps. 6.2 milliamps means 6.2 times 10 to the minus 3, or 0.0062 amps. Okay, so they will always give you these prefixes, and you need to know what milli means, what micro means, what kilo means, what mega means, and so on. Make sure you know them before your GCSE. If you do it to 3 significant figures, you'll get 95.2 ohms. And if you do it to 2 significant figures, you can round it up to 95 ohms. Okay? So there's another question done. It then says the graph shows how the resistance of the thermistor changes with temperature. So your teacher will have gone through this with you. As the temperature increases, describe the relationship between the temperature and the resistance of the thermistor. So I wrote, as the temperature increases, the resistance decreases. So it's an inverse proportion, yes? Or you can say the relationship is non-linear, okay? So it's an inverse proportion. If one goes up, the other goes down, okay? So that's one mark for describing the pattern, and another mark for describing the non-linear nature of the relationship to give you extra depth. The next part of the question, it says explain how the reading on the voltmeter, see the circuit diagram to make sure you know where the voltmeter was, which was across the resistor. Explain how that reading, the voltmeter reading, changes when the temperature of the room decreases. Okay, so let's go back and have a look at the circuit diagram. Yeah, so let's just rub out some of them. We don't need these anymore. So the voltmeter is 0.9 volts, yeah? So we want to know what will happen to this 0.91 volts. Is it going to change? How is it going to change? So we need to go now look at the question. So here it is. We'll explain how the reading on the voltmeter, which is across the resistor, changes when the temperature of the room decreases. Remember, when the temperature decreases, the resistance of the thermistor increases. So that's the first thing you need to write, that the resistance of the thermistor increases. That's one pattern that you've got to notice. So its share of the voltage also increases, yeah? Or you could say the current in the circuit decreases, yeah? Because if it gets colder, the total resistance of the circuit will also increase. Therefore, if the total resistance in the circuit increases, the current in the circuit will be reduced. Okay, which means the voltage on the voltmeter will also decrease if the current is decreased. Yeah, so they want you to have the underlined bits that I've put where the ticks are. Okay. So hope that makes sense. There's another question done. Here's the mark scheme for the third question, part A. I'll let you stop the video if you want to have a look at it. By the way, POT means powers of 10, so if you forgot to change the prefix, you'll only lose 1 mark because you still used the correct method. Okay? That was the power of 10 linked to the 0.062 for the milliamps. Okay? And then part B is there, okay? And here is a question which will only come in paper 2 in Edexcel IGCSE. So if you're watching this video and you're doing double science, this will not come in your exam. It only comes in the physics IGCSE, the separate physics. And it's a question which is based on the quality of your explanation, and it requires depth, detail, and clear reasoning. And we'll have a look at the mark scheme afterwards. Okay, so you got a fuel pipe made from material that's insulator. That's like a rubber hose on the fuel pipe, just like in a petrol station. And you can see that there's a metal wire connecting the hose to earth, and also to the nozzle is connected to the plane's body. Okay, so they want you to explain why transferring fuel can be dangerous. So refueling a plane can be dangerous, and how. So you want something about dangers and how the use of metal wires makes the process much safer. So basically, what I've done is I've divided it into dangers and safety. So safety is to do with the metal wires, and you can see there's 6 marks available. So it's really a matter of being able to get your English sorted. Your English in physics needs to be really clear, and I've summarized it by the red. If you just put the bits in red, you probably get 2 marks. Yeah, so you need to mention sparks, dangers of explosion because fuel is flammable, and wires can conduct electricity or charge to earth. Okay, so the red bit will get you up 2 marks. If you go to the blue section, it says a build-up of static charge. Yeah, so whereas the bits in red don't talk about the build-up of static charge. Yeah, and this happens on insulators. So the build-up of static charge can only happen on insulators, because if it's a conductor, it will conduct the charge away, so there won't be a build-up. So it says it's prevented because metal wires, will conduct the charge to earth. Okay? So, and then for the green bit, additional detail, the spark is caused by a build-up of static charge that is high enough to create a high voltage between it and something else. Okay? Something that's uncharged. It says not enough voltage can be built up as the wires conduct the charge to earth. So this is additional detail, and that will get you closer to the 6 marks. So that's the depth and detail and clarity of your reasoning and how well you are explaining it. That will determine whether the examiner gives you 6 marks, 4 marks, 2 marks, or anything in between. Okay, so that's a 6-mark question, and here's the mark scheme. So the points that you need to make regarding the dangers are listed here. Friction, as fuel flows through the pipe, that's what creates the charge. That is what the build-up of static electricity is due to, or electrostatic charge. The potential difference between the nozzle and the plane could cause a spark. So if the nozzle gets charged and the plane is close to it, you can get a spark going from the nozzle, which gets charged, to the plane, which might be at a different voltage. This is what causes the spark, which can lead to explosion or fire. So these are the dangers. And then the use of metal wires is the safety aspect, yes, or the precaution that they take. And the potential, if you have the wires, it makes sure that the different surfaces are kept at the same potential. Yeah? So if the potential is the same, there's no potential difference, so you won't be able to have a spark being produced, because a spark is produced due to a potential difference. Yeah? And the wires eliminates the potential difference. So if you don't have a potential difference, you basically have no electric field for it to create a spark, because the excess charge, yeah, has been earthed, and it has a constant ability to discharge safely to earth. Yeah, you won't end up with an imbalance of charge, or in this case you could mention electrons. Okay, so I hope that makes sense. And then over here they've explained that for 2 marks the elements of your understanding in physics is inaccurate, lacks sufficient detail, and you have some structure and coherence, but you may have missed some important points. So that's the 1 to 2 marks. And then for 3 to 4 marks, what they're looking for answers where the physics is mostly relevant. Yeah, even though you may include some things which are inaccurate, you can get 3 to 4 marks. And your scientific ideas are not fully detailed or fully developed. That's things that you didn't think of saying, but it's mostly clear, coherent and logical. That will get you 3 to 4 marks. And if you have accurate and relevant physics throughout your answer, that's what they're looking for, 5 to 6 marks. And your ideas are detailed and fully developed, yeah? And the structure is also clear, coherent, and logical, okay? So these are what they're looking for. Hope that makes sense. And these are the toughest questions for students. So the language questions in physics are far more difficult than the mathematical ones. And they've got additional guidance here so you can stop and have a look, yeah, to see if it helps you work out what you could have put or what you did put, whether you think it's good enough, okay? And that takes us to the end of this YouTube run-through of this electricity revision. So whether you're doing it in year 11 and want to just remember, refresh yourself about the kind of things that you could be asked in the exam, or if you're in year 10, you're just starting your GCSE journey. I hope you found the video useful. Don't forget to like it, share it with your friends, and make sure you subscribe if you want to get future videos of this nature, and be informed when they are uploaded. Thanks for watching. Catch you in the next video. Bye for now.